So now that you have an inkling of what the Java Completable Futures framework can do and sort of how it's designed, or at least what its intended purpose is, let's talk about how that overcomes these limitations with Java Futures. And again, this is just a starting point. We'll see this in more detail as we go through it later. So the Completable Futures framework overcomes pretty much all the limitations with Java Futures we talked about before. You can explicitly complete a completable future, whereas you can't explicitly complete a Java future. So here's an example. We could go ahead and create a completable future with no computation associated with it. We could start a thread that will do some processing. We could have that thread running in parallel with other things. And then at some point, when this thread reaches a point where it's got a result, it can say future.complete. It can pass the result in. And at that point, any thread that's waiting or trying to get the result or trying to join with the result will unblock. You can explicitly complete a completable future, which you can't do with a future. Something else you can do, oh, and by the way, these are I'm going to go through these examples very quickly because it's an overview. We'll go through them in more detail later. You can also chain together a bunch of completion stage methods and factory methods on completable futures so that you can handle asynchronous results fluently in a very efficient and clean way. And here's a good example. So let's say we want to reduce a big fraction and print it out and so on. So we could asynchronously invoke a function that will reduce a big fraction. And when that's finished, then we can go ahead and convert that result to a mixed fraction as opposed to a, I think it's called an improper fraction or something like that. And then when that's done, we can go ahead and print the result. So this is a good example of a fluent interface where we kick off an asynchronous operation, supply async returns a completable future. When that operation is done, we then apply this operation. This returns a completable future. And when that's done, then we go ahead and apply this action, and that goes ahead and prints the result. So the action of each completion stage is triggered when the completable future from the previous stage completes asynchronously. So notice how cool that is. We can kind of compose things together very cleanly. You simply can't do that with regular classic Java futures. Another super cool thing you can do, and you'll get a chance to play around with this in the next assignment, is you can have a single future that will be triggered when a collection of other completable futures that are running in the background in parallel complete. So only when everything is done will that one completable future get a chance to trigger. So this is a way where you can easily and efficiently and reactively wait for a bunch of asynchronous computations to complete and then have a single completable future triggered in response to that. And you'll get a chance to play around with this. It's really super cool. So in this case, we're going to go ahead and collect all the results. We get a single completable future to a list of results. When all those things finish running in the background, then we go ahead and print the results, but only after everything else is done. So we have a single future that's triggered when everything else finishes running asynchronously. So that's really super cool. And you'll also notice that this example illustrates how you can combine completable futures with streams. So we have a whole set of streams here, a sequential stream where we generate a bunch of big fractions up to a certain maximum. We reduce them, which will end up creating a stream of completable futures to a bunch of things that are happening in parallel. And then we collect them all up. We get a single completable future back, and then we wait for that to finish. So this is that tasty combination of completable futures on one hand and sequential streams on the other. OK, so that just gives you sort of a sense of how completable futures overcome the limitations with Java futures. That was a bit of a whirlwind tour, so don't worry, we're going to go through this all in more detail. I just want people to kind of see the big picture view, that there's a reason that completable futures exist, and it's largely to overcome the limitations with classic Java futures and provide a much needed reactive concurrent programming model that processes operations asynchronously and triggers dependent actions as asynchronous operations complete.